The person who discovered photoelectric effect was known as Einstein. Do you know Einstein? Albert Einstein? Albert Einstein?
No.
You don't know Albert? You don't know Albert Einstein? Okay.
Yes.
Okay, let us see what Albert Einstein is saying. What he is. So let me start from here. There.
We can't hear anything.
Okay, now students, at that point, people were arguing, they were saying that light is made up of particles, others were saying that light is made up of waves. So later they discovered that light is in the form of a wave or a radiation, and that's why it can be able to liberate electrons from the metal surface because it is in the form of a radiation. So let us proceed and okay, so let us come back to the lesson. And I think some of you are not hearing anything. I don't know what happened with your speakers. Even my ear. But at least
Even me.
if everyone was not hearing anything.
Yes.
Yes, please. No.
No. Who was hearing what was on the screen? Okay, I think you were seeing the words on the screen there. What?
Yeah, we're seeing the words on the screen.
So if you are reading, so they were trying to show you that these two, Albert Einstein and his colleague, they discovered that light is made up of a wave, and at the same time also light behaves as if it is made up of particles, which are called photons. So when we are looking at photoelectric effect, we use the phenomenon that light is made up of a wave. So light is made up of a wave, or it is made up of a radiation in the form of an electromagnetic wave, as I told you earlier on. So this radiation is the one that liberates electrons from the metal surface. Whenever that radiation is incident on the metal surface, electrons will be liberated. So that is photoelectric effect. Now, if we go back to this diagram here, what are they saying? They are saying that, let me try to minimize this, maximize it. So here they are saying that electromagnetic radiation, for example, ultraviolet radiation, are directed onto a cathode. So these are the radiations which are directed onto the cathode. This is the cathode. And supplies sufficient energy that causes liberation of the electrons. So the energy of this radiation incident on the cathode, on the zinc cathode, or on the metal, that energy is used to liberate the electrons, is used to inject out the electrons from the metal surface. So for us to remove those electrons from the metal surface, there must be energy that is needed. That energy is from the incident radiation. That energy is from the incident radiation. So the incident radiation must be energetic, such that its energy is able to remove the electrons from the metal surface. Once it is able to remove the electrons from the metal surface, these electrons will be liberated. They will be injected out of the metal surface, and they will move towards the anode. So that process where electrons are liberated from the metal surface is what we call photoelectric effect. So the electrons are then attracted by the anode and produce current in the circuit, hence the ammeter deflects. So at home you have the ammeter, isn't it? That ammeter is used to measure the current that is flowing in your house. So we have ammeters in the laboratory. We have seen ammeters in the laboratory. I may show you the ammeter. Have you ever seen an ammeter?
No.
Let me show you the ammeter here. So these are the ammeters. I think you are seeing. I think you know this one, isn't it? This is the ammeter. These are ammeters. You are not seeing? Are you seeing members?
Yes, please.
Okay, so we have seen these ammeters. These ammeters, the red is positive, the black is negative. So when you are connecting, this ammeter deflects whenever there is flow of current, and it is used to measure the current that is flowing in amperes. This M means amperes, this M means milliamperes. So it means that this one is measuring small amounts of current, very small, because milli is something very small. millimeters, milliwatts, so milliliters, so milli is for something very small. So these are milliamperes. A is the unit of current, and A is called amperes. We call A what? A is what we call, capital A is what we call the amperes. Amperes is the unit of current.
Okay.
So the ammeter is used to measure the flow of current.
Current.
Very good. Okay, so that's why it is connected there. So once that ammeter deflects, then once this ammeter deflects, then we shall know that there will be current that is flowing in our circuit. But that current is brought about by the electrons which are flowing from the zinc cathode to the anode. Whenever electrons move from one point to another, then current flows in the opposite direction. If electrons are moving from the zinc cathode here to the anode, then current is going to flow from the anode to the cathode in this wire, in this direction like this. Okay, so they're saying the flow of electrons to the anode completes the circuit. What is the circuit? This is the circuit. Circuit or circuit. The circuit is this wire here, the battery, the watt, the ammeter, and our tube. So this is the full circuit. So if the electrons are flowing from this point to this point, so it means that we shall have current flowing from here up to here, because current flows in the opposite direction to the flow of the electrons. So electrons will be flowing from the cathode to the anode, but current will be flowing from the anode to the cathode in the opposite direction. Okay, so they are saying that the flow of electrons to the anode completes the circuit, and hence an electric current flows which causes the ammeter to deflect. So what has brought all about this current that is moving is the photoelectric effect, where a radiation was incident on the metal, and that metal started producing electrons, and these electrons emitted from the cathode are attracted to the anode. Once the electrons are moving from the cathode to the anode, and the current will start flowing. So the current flows, and once the current flows, it is measured, it is detected, or it is measured in the ammeter by seeing the ammeter deflecting. I've showed you how the ammeter looks like. So the ammeter will deflect. That shows that now there is current that is flowing, but that current is due to the photoelectric effect. They are saying, note, the magnitude of the current produced is proportional to the intensity of the incident radiation. So the magnitude of the current, so that means that if the intensity of the light increases, so expect large amounts of current that will be detected in the ammeter, or large amounts of current that will start flowing, large amounts of electrons. How do we get large amounts of current flowing if the intensity of light increases? If the intensity of the light increases, so it means that more electrons will be liberated, and once more electrons will be liberated, we shall see more current that is flowing. So I say that if the gas is introduced, now remember that this is a tube, this one here, and this tube is a vacuum. What is a vacuum? Space with no matter. So there is no air. There's no air inside this glass tube. What is there is only the anode and the cathode only. There is no air. So if we introduce air particles, or if we introduce a gas inside this tube, current decreases slowly because the gas particles collide with the electrons. Members, are you seeing the reason?
Yes.
It is because the gas particles will collide with the electrons. Remember, these are electrons. So inside you'll be having gas particles. So let me try to, I can do something here. So if this is the tube here, and this is the cathode, and this is the anode. Okay, so this is our cathode, and it is concave like this. I'll give you the reason, or you can give me the reason later on. And this is the anode. Anode, come on, anode. So this is the glass tube. The glass tube is a vacuum. So no air, no what? No air particles. So when a gas is introduced, suppose we put a gas here, what will happen if there are gas particles introduced inside? And we have our radiation incident on the cathode producing electrons. It means that now these electrons are likely to collide with the gas particles. The electrons, these are electrons, these ones, they are called electrons, or they are called the cathode rays. Cathode rays is a group of fast-moving electrons, a group of fast-moving electrons. I can zoom in there so that you can see clearly what I'm talking about. So try to zoom in there very well and you see. So this is the cathode, and this cathode, on it there is a radiation in form of an electromagnetic wave, maybe it is light. So it is incident on this cathode. This cathode will produce electrons. Electrons are going to be liberated or ejected from this metal because this radiation has sufficient energy. Now these electrons which are flowing from the cathode to the anode, because the electrons are negative, they will be attracted to the anode, which is positive. So if they meet the gas particles which are introduced inside the tube, they will collide with them, and these electrons are likely to lose their energy. So these are electrons moving. But once they collide with the gas particles, once they collide with them, the electrons lose their energy. And which energy do the electrons have if they are moving? Members, let me ask you that question. Which type of energy do the electrons have if they are moving? Who knows the answer? Cynthia? Yes? Cynthia, I'm not getting you. Speak again. Cynthia, I'm not getting you. There's a problem with your microphone, Cynthia. I'm not getting you. Maya, what's the answer?
I think it's the kinetic energy.
Exactly. Those are, it's what we call the kinetic energy. So the energy that these electrons have if they are moving from the cathode to the anode is kinetic energy. So once we introduce a gas inside, the electrons will collide with the gas particles. These are gas particles. Sorry, gas particles, and the electrons will lose their kinetic energy. So it means that the electrons will have insufficient energy to reach the anode. So if they don't reach the anode, what does it mean? It means that hence reducing the number of, we shall have a few number of electrons reaching the anode. And this means that also the current that is flowing is likely to reduce. Because if you have less electrons reaching the anode, it means that also the current that is flowing will reduce, because current depends on the electrons flowing from the cathode to the anode. But if a few just reach the anode, then also the current decreases. Why? Because the electrons collided with the gas particles. When they collided with the gas particles, they lost their kinetic energy. Members, are we together?
Yes.
Yes.
Yes. Okay, now give me a reason why is the tube now made a vacuum? Why do we have to make the tube a vacuum? Can you give me the reason? Why should we make the tube a vacuum? Why should the tube be evacuated with no air? Yes, Sandra. Anyone knows the answer? Put up the hand. Just put up the hand if you know the answer.
In order to prevent air from entering.
Air from entering. And what if air enters? What happens is what happens if air enters? It's what we want to prevent. What air causes when it enters is what we want to prevent. So what is that? Yes, Patricia, do you know the answer?
Air may collide with electrons.
Air may collide with electrons, and when it collides with electrons, so the tube is made a vacuum to prevent air particles from what? To prevent air particles from what? From colliding. Patricia, from colliding.
Colliding with the electrons.
With the electrons. Prevent air particles from colliding with the electrons so that more electrons reach the anode. Okay, so more electrons will reach the anode, and that means that we shall have more current that will be produced, and current increases. Stop. All right, now what are the conditions? What are the conditions for photoelectric effects? So conditions for photoelectric effect, the nature of the metal. I told you that these metals, not all metals will be able to liberate electrons whenever a radiation of sufficient energy is incident on them. Not all metals. So the nature of the metal, the nature of the metal is one of the conditions of photoelectric effects. So zinc, I talked about zinc. The zinc metal is one of the metals. The zinc metal. I'm going to ask you students from your chemistry. Is it having a negative
Valence.
It's positive valence. It has 2, isn't it? Is it written like this?
Yeah.
Something like that? That is zinc, isn't it? I wanted you to share with me your screenshots. I mean, with your so this is zinc plus 2 here, isn't it? So okay, zinc is used as a cathode because it is good at producing electrons. Then the other part, one of the conditions is the frequency of the incident electromagnetic radiation. It should be noted that the electrons are emitted until a certain frequency called threshold frequency is reached. Called what? Threshold what?
Frequency.
A threshold frequency is reached. So, sorry, called threshold frequency is reached. So, there is that frequency. You study later on if you reach your senior 5. It's called, note it as F0, called threshold frequency. So that frequency below which no electron is emitted is a frequency below which no electron is emitted from a metal surface when radiation is incident on it. So that means that there must be a certain frequency of that radiation. A certain frequency. Frequency is measured in hertz. Those are the units, hertz. Okay. We shall look at this more if you are looking at waves with you guys, I think. So hertz is the unit of frequency. So a radiation must be having a suitable or a certain frequency at which electrons are emitted. So those are the two conditions. One, the conditions, the nature of the metal, and the frequency of the incident radiation. Members, let me invite questions. If you have any question, before we go to thermionic emission.
Excuse me, teacher.
Yes.
Teacher.
Yes.
Teacher.
Yes, Patricia.
Excuse me.
Patricia, your next.
What is meant by threshold?
What is what?
Meant by threshold.
Threshold. Threshold frequency. What is meant by what? Threshold.
Yeah.
Is the name
That one.
Is the name given to the frequency, threshold frequency.
Yeah.
This one is the minimum frequency. Minimum frequency below which no electrons are emitted from the metal surface when a radiation falls on it. Is it okay?
Yes.
It is a minimum frequency below which no electron. It is the minimum frequency. Minimum. Below which no electron is emitted from the metal surface when a radiation falls on that metal surface. Okay. Another question, members. Any question? Should I ask you?
No.
I don't ask you. Let me ask you something here. Okay. Some of you have looked at lights in your former. I want us to zoom in very well. Let me zoom in for you here very well. Do you see the zinc cathode here? It is made concave. Do you see this shape? It is curved, isn't it? Members,
Yes.
unmute. It is curved. Who can give me the reason why it is made concave? Why is the cathode made concave?
Teacher, to trap light.
To trap light. Is that one? Why is the cathode made concave? Why is the cathode made concave? To
Supply sufficient energy.
To supply sufficient energy. I'm not seeing people are answering because they're not giving me your name. So let me first see. Okay. Patricia, you said yes. Cynthia Katriza.
Supply sufficient energy.
To supply sufficient energy. Thank you for trying. Melvin, where's Melvin? Who is called the Fusinguro? Unmute. Singuro, unmute. Okay. To reflect light, Sherry, to reflect light. To reflect light. Okay, to reflect. You should use the right terminology there and to reflect. Do you see concave mirrors? Have you ever seen concave mirrors? Members, have you ever seen concave mirrors? Yes? Concave mirrors.
Yes.
What's the use of concave mirror? Why do you think they are made concave? Concave mirrors. This is one of the concave mirrors. Are you seeing this? This is concave, isn't it? Concave. This is concave. Concave mirror. This is now a mirror. Also, a cathode is made in this form like that. So the purpose, do you see the light that is incident on this mirror? This one here.
Light.
This light rays that are incident on this concave. Are you seeing them? They are converged at one point, isn't it? This point.
Yes.
So also the cathode is made in such a way that the incident. Let me go back to the notes. The cathode is made a way that all these electrons that are going to be liberated from this cathode are going to be converged onto the anode. Are we together?
Yes.
So all the electrons that are liberated from the zinc will be, because I told you that I showed you here that the cathode is made in this form like this. So all the electrons that are going to be emitted from this cathode will be converged at the anode, such that we don't have stray electrons moving in a different direction. So that's why we converge all the electrons that are emitted from the cathode onto the anode. So the great answer there that we can write is, in order to converge the emitted electrons onto the anode. Are we together?
Yes.
Okay. So you note down those answers, members. If I write something, you write it. Wrote down that question. So it's all right. So members. So when we meet, I think I should have. Should I have another? I think I should have another lesson with you. Maybe this week we shall see. But senior twos, tomorrow with senior twos, we have a lesson for only senior twos, and we shall be looking at pressure, to understand pressure. Now, when we meet, we shall look at thermionic emission. Sorry, it was supposed to be photoelectric effect in the topic, but I put thermionic emission. So when we meet, we shall look at thermionic emission. Are we together?
Yes.
Yes. So you go to the website and download this book. It is, I don't know how many pages, but it has 248 pages. You download it, you can print it and bind it. You may print it and use it as your notes because you have limited time. And also, today I'm not going to give you an exercise, but I want my exercise, this exercise done. Are you seeing it?
Yes.
Up to number 12, do that exercise and finish it. When we meet next time, we shall look at anionic emission, cathode rays, their properties, what is...
Yeah, let me take a look at it.
So,
What's the name of the book?
what's the name of one?
What's the name